Okay guys, so we're going to look through the second day of 7.1. It's really 7.1. It's a little ahead of myself with my 2. 7.1 solutions. We are given, in this case, identities that have a left-hand side and a right-hand side. And I told you in the warm-up video that you needed to work on one side. Okay, I'm going to choose to work on the left-hand side and see if I can make it match the right-hand side. But I probably won't do anything to this side at all. Okay, so on the left-hand side, the math that I'm given is two binomials next to each other, which means multiplication. So I'm going to multiply. I'm going to multiply 1 times 1 and get 1, 1 times cosine and get cosine, negative cosine times 1 and get negative cosine. Those cancel. These are conjugates. They have the same number in the front and back, and a plus and a minus. So this is difference of squares. So we end up with 1 minus cosine squared theta on the left-hand side. That is equal to the identity sine squared theta plus cosine squared theta equals 1. If I rearrange this, I get sine squared theta equals 1 minus cosine squared theta. I can replace this with sine squared theta, and I'm done. So you take one side, you simplify it in some form, and then you manipulate it so that you get. I pretty much do all of these the same. For number 14, I'm going to manipulate the left-hand side. I'm just going to work on it. I've got cosecant is 1 over sine of x minus sine of x. I'm going to get a common denominator, which is sine of x. So I'm going to multiply this one by sine of x over sine of x. That's using the identity property. That gives me 1 minus sine squared x. 1 minus sine times sine is sine squared. They're both over sine of x. Sine of x. That is equal to cosine squared of x. It's the same manipulation as this Pythagorean theorem over here. So 1 minus sine squared is cosine squared over sine of x. If I rewrite that one more time, I have cosine of x times cosine of x over sine of x. And I've written it in such a way that it looks like this, because cosine over sine is cotangent, and I'm done. I'm writing it very linearly, I'm not sure that's a word, but I am taking one side, the left-hand side, working it all the way down until I have it where it looks like the right-hand side, but I don't do anything to the right-hand side. It takes up a lot of paper, but it's very methodical, and that's really what algebra is. It's some system where you can use rules to get from one place to another, and everybody gets. 15, looking at it, as I wrote it down, I thought, well, the right-hand side in this time has something that I really want to change. Cosine of negative y. Cosine is an even function. So when you plug in a negative number, you get the exact same value out. So I really want to write cosine of negative y as cosine, and I'm going to do that. But look at that. It's multiplied by secant. So what is secant? Secant is 1 over cosine. So I'm actually going to manipulate both of these because they actually both equal 1. I think that will be the easiest route. So on the left-hand side, the right-hand side, secant is 1 over cosine, and cosine of negative y is cosine of y, and these cancel, and I get 1. Over here, there's another Pythagorean identity, which is right here, which I'll write down for you. Tangent squared of y in this case, plus 1 equals secant squared of y. And if you rewrite this, if you move the tangent over here, you get 1 equals secant squared y minus tangent squared y. So I can replace this whole thing by 1, and I'm done. So I've proven it. I did it in both sides this time, but That's not always the case, but that seemed like the shortest route. Otherwise, I would have had to get common denominators and do a lot of work. This one didn't really have all that much work. That was 15. Okay, this one isn't as obvious to me as the last one, so I'm going to probably work on the left-hand side. It seems the most complicated, and see what will simplify out. So I have got cosine of beta. That fancy b is a lowercase Greek letter beta. So cosine of beta, cotangent of beta over 1 minus sine of beta minus 1 equals cosecant of beta. So let's see. If I rewrite cosine and I say cotangent is equal to cosine over sine all over 1 minus sine here, minus 1 minus sine of beta over 1 minus sine of beta. What does that give me? Well, that gives me cosine squared of beta, for these two multiplied together, over sine. If I have a fraction, this fraction, divided by this fraction, I can flip it over and say 1 over 1 minus sine of beta, which means now I have a new denominator. So I'm going to need to multiply this one by sine of beta over sine of beta. So what does that do for me? That gives me minus sine of beta 1 times sine of beta, negative sine, so that's negative sine squared of beta all over 1 minus sine of beta times sine of beta. I'm going to go up here and work on it some more. So what do I have now? I have cosine squared beta times 1, it's just cosine squared beta, minus this whole thing. That's really important. It's subtracting the whole fraction. Some of you would drop that, and it will change the minus, which changes all the signs. So parentheses are super important. So cosine squared of beta minus sine of beta plus sine squared beta all over, and I said before, yesterday's example, you should keep the bottom factored. So this is the same denominator, different order, but that's okay. Okay, how does that help me? Well, they are not together, but if I rearrange them so it says cosine squared beta plus sine squared beta, they are equal to 1. So these two together make 1 minus sine of beta over, so these two made 1. 1 minus sine of beta, 1 minus sine of beta over sine of beta times 1 minus sine of beta. So yay, those cancel. When things cancel, they don't cancel and make 0. They cancel and leave 1. They make the fraction 1. And 1 over sine of beta. That looks like, I don't know what that looks like. Sine of beta is equal to cosecant. Yay! So that one was kind of gnarly, but it can be simplified. You may have taken a different route. I would not be surprised if somebody found a shorter route than what I just did. Don't worry, the lights will come on. But that was the route I took. They don't always. Okay, this one, number 17, this is a really boring problem. If you translate sine of pi over 2 minus x, So sine of pi over 2 minus x, that's equal to save space, I'm going to write it right here, cosine of x. And cosine of pi over 2 minus x equals sine of x. And that's equal to cotangent of x. That's its own identity. So that one's done. There we go. Okay, and here's 18. So 18 says secant squared theta over tangent theta equals secant theta cosecant theta. So again, I'm going to take the left-hand route. Secant squared is equal to 1 over cosine squared over tangent is equal to sine over cosine. If I divide by a fraction, then I change the division into multiplication and flip it over. There it is flipped. And when I multiply this out and simplify, cosine goes into cosine and leaves 1 left over. So there's 1 left over here. I still have sine in the denominator. And I'm trying to say that instead of them being numbers in the bottom, I'm going to move them to the top. Cosine is equal to secant, and 1 over sine is equal to cosecant. And so we've proven this one. So basically we took 5th grade math and merged it with 11th or 12th grade or freshman or sophomore trigonometry, and we're doing division by fractions and the rules. So there you go. There is numbers 13 through 18. We will use all of these things to simplify. I need you to have the identities memorized so that you can do this work without having to look at the sheet and see what happens for you. So I have the sheet up so that I can point at it and explain it as we go through it, but they need to come to you. I know that the reciprocal identities probably already do, and so do the quotient ones. These might make a little sense, or you might be able to guess them. The period identities, they should be fairly obvious. Even or odd, cosine's the only one that gives you the exact same. The other 4 give you negative versions of themselves. And you definitely know this first Pythagorean identity. The other 2 you might have to memorize. So I feel like there's not that many that are new for you to memorize, but I'd like for you to work on them. Any questions? Be ready for our Zoom session, and you should have watched this video beforehand. Those were the instructions given on Friday. So come with your questions if you didn't follow the video.